great to be back here. We were here about a year ago and gave a talk, and it was a lot of fun, so we're going to do it again. And thanks to Dan and Nicholas for arranging all of this, and M2A for sponsoring. It's a great meetup, and I hope we can all be attend as many as we can. So, any case, our talk today is mainly about resilience and how we're doing our cloud production stuff. We can go into a bit more technical detail, things that we glossed over last time, and I think if you can really nerd out on the engineering if you want. It looks like a lot of the people in here are engineers, and so maybe that will be cool. Introducing us, we are very small. You're looking at the entire company. It's a 2-person company at the moment. We we used to work at AWS. Media Connect was the last product we worked on, and then we went off to do this. And so basically we're still based on the same type of stuff, where we want to do things in the cloud. I think that's definitely the future. It's a good thing to do. And the last time I showed these slides, Julian, the CEO of one company I founded before, told me later, those were the worst slides I've ever seen. So just for him, I'm reusing the slide deck stuff. And so Julian, if you're watching, enjoy. In any case, and those other slides, we said early R&D phase, and there's a change now where I'm saying late, because we're actually getting a lot done. We still don't have any managers, money people, board of directors, that kind of stuff. It's kind of what I call, engineer utopia, because all we're doing at the moment is writing code, and that's really fun. But that is going to change, and we'll be talking about that. So we're not selling anything, and we're bootstrapped. We make our money by doing contracting. At the moment, we're like inundated. We have a ton of work. There is a video company that you are all familiar with, who we can't mention. We're preparing a demo for them for NAB, and that's consuming a lot of time. Anyhow, but that's good. It helps pay our bills, and it's better than having, finance people telling you what to do. So anyhow, this is a brief outline of what we're going to do, we're going to talk about. We're actually going to go into the internals of our service in a little more detail, as much as you're willing to tolerate. We do want to talk about asynchronous processing, because that is one of the things that differentiates us from a lot of others, but not everybody, so we're going to talk about that. Talk about some of our recent work. We will do a demo. That's always fun. Risky, but fun. And then if there's time, we will have some discussion. So let's go right into the internals. So the use case drafter is a pretty familiar one with you now, especially after COVID. When we actually formed our company before, and when we mentioned doing this type of stuff, they were like, why? and like almost immediately everyone understood. But basically the idea is it would be great to do what's normally done in a broadcast production studio and distribute it so that people can work from home or wherever they want to be around the world. And in our case, basically what we're doing is you send all of your sources to the cloud, and we will manage that all. You get to still control them, but it's a software as a service that's running in the cloud. I showed something like this slide at the last time. This is basically sort of the block diagram of the way our system works. The last time we were trying to get you guys sort of understanding our workflow, which is weird. Okay, we do like proxy was on the ground, and we do full res in the cloud, not unlike the last talk where they were talking about sending proxies down. In this case, this is all live stuff, and we'll explain the reasons why we do this, but This is actually working out really well for us, and we also have this 1 second fixed delay, which is kind of like, why would they do that? And that's one of the things that we're going to go into more in this talk. But that's generally the idea is people get their sources into our system, and we send proxies down to every location on the ground. We do make it a fixed latency, so everyone who's working around the world, they're actually seeing the same proxies at the same time. So when the director says to do something, they're both looking at the same video. And we basically, run a switcher and stuff on the ground, and we're watching what they do, time-stamping the commands up and sending them up to the cloud where they get performed on the full res. And we managed to delay everything just right so that all the timing works out, and it's basically all frame accurate, 0 button delay, as they say, that kind of stuff. And but in any case, this is what we were showing you last year, and we just kind of, that thing where it says full resolution uncompressed switcher, that was just kind of, we said, yeah, we do that in this weird way, and we're going to go into more detail of that. So we are primarily data plane people, and so a lot of these talks, this talk especially, is really going to focus on how we do the data plane to make this work. And but I have to stress that it also requires a really unique type of control plane, and we're going to mention a little bit about it during the talk, but that's really like a topic for another whole talk, really. But it is kind of like a control plane designed by data plane people. It's a little weird. And one thing I want to do is to distinguish that we are not doing media microservices, okay? So that's one thing I want to make really, really clear. So we're not doing the EBU stuff. And actually, a lot of this stuff I did, some of you will remember, like at Elemental, I mean, Kubernetes came out almost exactly 10 years ago. And I was building stuff there where we were doing a lot of things with microservices as proof of concept that, I still haven't seen AWS deliver as product yet. But it was some really cool things. And so, I've been there and done that. And I really think that this architecture, as it's being actually standardized by some groups, including EBU, is maybe not the most appropriate way for doing things in the cloud. It doesn't leverage the cloud as much as, in my opinion, as much as it really should. And it kind of scares me, and I can see why some of the people who are trying this are finding that it's costing them a whole lot of money. Not to mention the fact that you have to, this is the cloud native landscape. Look at all these services. Look at all this stuff. It's like you need to understand all of this. And we actually use a couple of these in our service, but not very many. And nothing like a service mesh or anything like that. Let me see if I can get back here. And so I really wanted to show really how we differ from that. Maybe Jialu is going to have to help me with this part. So, yeah, oh, perfect. Thank you. So, yeah, basically there's some things in here. It says container service meshes, microservices, immutable infrastructure. We use some of that. But I think that it's interesting. Like, I was a principal engineer at Elemental. I was really into this. Then we got acquired by AWS. I really learned a whole lot about different needs for doing architecture in the cloud, and most of it was simplifying over what this type of thing is. And in our case, it's all basically custom for us, and it's purpose-built. And this is a good example. This is what we run on every instance for our data plane. There's a product, there's code called a flow router that's a very to write Rust code, actually, that does all the packet processing, sending all the stuff in and out. And just like a lot of people are doing, all the media goes into shared memory, and the apps access it through the shared memory. And in our case, I'm drawing a lot of arrows to show media flows, but that's not a whole bunch of different media streamed. It's not like different channels of video where we actually run very little on one instance. But what those really are flowlets. So it's sort of like, well, it's basically ways that we can do really reliable, this uncompressed video transfer on clouds like AWS. And we have talked about this more in like SMPTE papers and stuff. I'd be happy to tell you more about that. But in that case, that's the thing. And another like bit of secret sauce is every single instance has that circular buffer on it. And we'll get back to why that's interesting and important. But basically all media that goes in and out of any of our instances has storage, has memory, can go back and replay video if it needs to, and we do. And it amazingly simplifies the architecture. I mean, there's a lot of stuff. I mean, we used to have like retain release on every frame and all that kind of stuff. You can like ignore all of that basically because it's all going to get cleaned up in a couple seconds. So, and it was that we spend a lot of time working on that one. But this is it. I mean, this is kind of what's on every instance. There's no Kubernetes or anything like that. And basically, what we will show you later is it's a signal flow graph between instances, and those flow routers are what arranges all the media flow. We don't use anything like, multicast type stuff. And in a way, you can think of these almost as multicast routers because they do know like where to send the media to who wants it. And an interesting way that we do this is this is getting into the control plane a little bit, but I think it's a really important point for how our system is designed, is that you don't really directly have to talk to these things to tell them what they do. And they're kind of are listening to what's going on and know what to do. I call it situational awareness, but it's a lot like when you're in a TV production and everyone's on intercom and you know like which camera's on the air and who's going to go next, and you also can tell like when something is going wrong just by listening. I mean, that's why like airplanes are all on these frequencies and they can hear each other when things are going on. We take advantage of that in a big way, which I don't think I've seen other people do. And the situational awareness is really key to what goes on when we talk about resilience a bit later. So anyhow, I think that's something that I've never seen anyone describe before, but it's kind of cool. And of course, everything's like hitless failover. That's really easy to do when you have these buffers and stuff and you're already accumulating packets. So in general, it's really common to be sending 2 of the same source to each of these, and they can figure it all out. And so I want to go into a use case, and we'll take a vision mixer, and let's do like, this is like the type of thing that AWS is really pushing. This is a great product from VizRT. There's a nice control surface that the users get to use on the ground, and then there's a very pretty app and GUI that gets to run in the cloud. They view it over a remote desktop kind of connection. We'll get into that. And so an interesting thing that I want to point out here is that with these types of things that are kind of lift and shift, the size of the instance really determines like how big and complex you can be. So with things like a video switcher, you don't know what the next button is going to be pressed or the next source, so you have to have them all available, and that kind of limits how many can get onto your instance. And it's really weird because the processing is sort of related to how many ME units you have, and everything else is almost like a switch matrix. So anyhow, putting all of that on one instance it really limits what you can do. Let's go into this a little more. So like I was telling you about this contract, it is a lift and shift thing, and it is actually running on CDI. And we were just looking at what would happen if we have to run it on GPU instances. And please, AWS people, correct me, but the cheapest GPU instance I could find on AWS right now is the P3DN24X large. And that costs $31 an hour to operate. So It's like, and notice, can you see it? The spot price is so much lower. So it's like, it's almost affordable with a spot. And if you're doing stuff like putting your GUI in the cloud and your GUI is requiring GPU, you really can't use spot instances for that. So you're paying a really big price. And so one of really our tenets is we really want to keep the GUI on the ground. We really like good native GUIs, but they really belong on the ground. We'll show you more about how to do that, how we do that. And I also want to point out that the C5N9X large from AWS is a CDI-capable instance. It's very affordable, in my opinion, and it's great. It's actually just slightly more expensive than the largest instance that we use. So we don't use CDI except when we need to gateway to somebody who's on CDI. But so like the biggest so that's basically like just slightly more expensive than the biggest one we ever use. But there's another kind of hidden thing in here is as you go up on these, the availability of them becomes much more difficult. So you have an elasticity problem. So if you rely on certain of these, it's really hard to like replace them quickly. You may not get it. You might get iced. And the other thing that we're noticing is the amount of bit rate it takes to be able to view these GUIs. And this is using the nice technology from AWS, which is really good, extremely good. And the screenshot I made was actually we were in AWS office in a demo in New York, and that was using, what was it, like 41 megabits peak and 21 average. And the other thing I noticed is like, if you happen to be using a Windows instance, you actually have to pay this $200 remote license thing for using Windows Remote Desktop, even though you're not using Windows Remote Desktop when you use this. So I don't know. To me, I think putting your GUI up in the cloud is kind of an anti-pattern, and I hope you don't do that. So now I'm going to talk you through the use case to show you like how we actually handle sort of a typical video thing. So I'm going to take like an example, a little storyboard from, I used to work in TV news, so we're going to start with that. So here's like a really simple thing that just has a couple cameras. There's a ENG remote thing, like live shot, microwave when I did it, who knows what it is now. There's a player and a character graphics thing. And what we're going to show is we're going to start out with the anchor, we're going to put a little super over it, then we're going to DVE in the little, the ENG thing, we're going to go full screen with them, and then we're going to cut to the playing the actual story. So this is what it looks like on our system. The camera one thing, when you're just showing this one camera, it's just the input goes straight to the egress. The flow routers know that they don't have to put any processing in there. Moving on, once we have to add like a CGI thing, then suddenly we have like an ME unit. So these are really, really tiny. These hardly are running any cycles. This is really, the reason we're putting them on so many instances will become obvious a bit later. When it gets a little more complicated, when we have to DVE the guy in, this is a little bit more complicated. So there's more instances being used. It eventually starts shrinking down. And when this whole thing is in order to enable a dissolve into the playing the story. But so in any case, I guess that's one of the things I wanted to point out is we just run, basically we run an ME on every instance. Doing that lets us have as many inputs as you want. You can have as many MEs as you want. I mean, you can a gigantic switcher, world's biggest switcher. I mean, there's nothing that limits it other than availability of instances. It looks like, Okay. And this is just the slide actually from last year, where we just wanted to point out the fact that the not your problem part is we are a SAS. It's weird how the images colors look totally different. But in any case, we do have a web app and an API that you access sort of in the normal way, although we do have WebRTC live preview, unlike AWS. But the other part is that the controls on the ground are actually talking to this message bus, which is, that's part of our, what we call central nervous system. In any case, that's another way that we can get the really quick interaction. And I want to go into async a little bit. I'll go really fast if you don't care. But I had this whole long history of synchronous processing. We ripped it out because only old people care. But the general idea is with synchronous processing, the media comes in according to a clock, and you have to sample it at the clock time. And if you miss it, well, too bad, you just lost that frame. So in this case, I draw these blocks, and I draw them like in a darker color when they're using more CPU. I mean, when we do synchronous processing in the cloud, basically we do some processing and then we're waiting for the next clock. And you can, because of the scheduling in the cloud and just the way OS scheduling goes, you can sleep for a certain amount of time, but then you end up always having, at least in my code, you always have to do a spin loop until you get exactly on the next time. So you're using up a lot of energy and wasting time just burning up a thread, basically. So in any case, like in the bottom one, that processing took a little bit too long, and suddenly we missed that frame, and so we're spinning for even longer, and we dropped a frame. So anyhow, this, to me, I mean, this happens to code in the cloud a lot, in my opinion. So with async, it's a lot easier in a way, is you process and then you basically fall asleep waiting for a callback that says, hey, a new frame has arrived. And this, you have to rely on timestamps. You have to follow the timestamps to get everything working. And in our case, well, there's variable delay, and it definitely allows faster than real-time media transfer. And that is definitely being used. So we thought it was going to be really trouble to try to sell async to people. And then we were like really happy when we were at NAB last year and Matrox introduced this origin system. And so suddenly there's like a big name that's selling async. And so that was so great. We went and talked to them and like, oh, finally somebody's doing that and all that. And they said like, oh, do you want to use it? And we're like, no, we already wrote our own. But it's really nice to see some attention there. And I think one of the things that they really feature is their latency. They can be like incredibly low latency, and they also try to have the same architecture on the ground and cloud. And both of those are definitely things that we're not after. We definitely leverage the cloud. I would use a different architecture for the ground than the cloud. I wouldn't try to make it the same. And we've already said we don't care about latency. I mean, we set it to 1 second. So, and there's another observation. If you really start working with async, if your media is coming in synchronously, it looks like this, basically, is everything still kind of follows a clock because you're basically waiting for that next synchronous media sample. So it's not like a perfect win for you because you are still waiting for those frames to come in. But where it all really helps is in resilience, helps us, the whole reason we're using it. So I'm going to go back to one of these more complicated signal flow graphs that we were using. And a typical type of way of establishing resilience is these two colors, and I guess red-blue is used a lot. And in this case, you just duplicate your processing twice, or at least twice, and then you take the good output if one happens to fail. And this is really good, especially for going across AZs, availability zones. We actually have to use a form of this in that case, but you end up with what I call a 2N solution. You build double of everything, and it can be kind of wasteful. But then, so yeah, ME1 just burned up, so basically the blue route is going to egress. So instead, what we use within an AZ is this repair node type of resilience. And in that case, we call it N+1. There's always a node ready to take over if somebody dies. And it turns out, and I should have made a graphic that shows this, but if ME1 dies, it gets detected by the system with plenty of time to be able to send everything to a repair node, because we're taking advantage of the fact that we've stored up the media, so everybody knows, the upstream nodes that were above ME1 knew, they can resend that media faster than real time to the repair node. And the amount of work done on that node is small enough that we can actually catch up. So in this case, N+1 within an AZ it works really well. And sort of in practice, what happens is even easier than this, because the changes happen on like a switch. And in that case, it's much easier to repair than if it was like halfway through a frame or something. So that's basically why the whole reason we put in that induced latency, it was to get the ground, part of it was to get the ground control flow up there. But basically here, you can see that around frame 30, if an input frame comes in a 60 frame per second system, we don't even start processing it until 30 frames later. And we will have received all the control information by about frame 24. And so everything is all set up and knows what to do. And the longest processing I've ever seen has been like 36 or about 6 frames. So at about frame 36, it leaves the media processing and basically just goes into a big buffer. And that buffer goes to a synchronous gateway that goes out. And so the amount of buffering in that can change when you do repair, but it actually works, in my opinion, it works really well. But that's a little bit more information on how we do it. So there's what we call our repair window, which in this case is around 24 frames. So that's the summary. We take advantage of the public cloud. We do multiple small instances with quick per frame processing. Everything is faster than real time. Because these instances, another thing I didn't go into that much is because these instances are so small, the control plane can spin up, almost anything. There's a huge variety of instance types we can spin up, and for elasticity. And because it's so easy to work around problems, the control plane can also kill expensive ones and replace them with cheaper ones as they come up. So we can use spot instances and all that kind of stuff. And we do take advantage of async in that way. So that's just going into something that we didn't go into last year. Maybe next time we can talk more about the control plane stuff. But here's like what we're up to now. So just as live sports, I used to be at University of Washington, and it was Pac-10 at the time I was there. Now it's Pac-12, and we've been discovering that live sports are a really great opportunity for services like ours, and especially because there's tons of chaos going on right now. And Pac-12, I think, is a great example. So they have this really, really, really nice studio that they built. So, ASG probably made a lot of money. They like to brag about it. The second largest 2110 facility on the West Coast. And Pac-12 has been doing this for a long time. I mean, even when I was at Elemental, we went and visited them and saw them sending all their stuff back to a central location for processing. It was great. So they have in that control room in the upper right, that's one of 9 control rooms they built. And the lower thing is that's like replay stations, and I don't know how many of those they totally have. I guess we can ask ASG. But then, if you're probably aware, boom, Pac-12 is imploding in a few months. There'll just be 2 schools there. So, I don't know what they're going to do with all that stuff. They'll probably figure out something, but I think that's an example, and we've been attending a lot of conferences about sports, and we really think that there's a lot of opportunity here. I mean, it's almost to the point where every team is almost having to become their own broadcaster, and in that case, I think it really pays to have a SaaS, because you really want to concentrate on your core strengths rather than build up a 2110 facility or something like that if you don't have to. So anyway, we think that's interesting. In order to do it, we've suddenly had to add a lot of other stuff. When we built our service, we started 4 years ago. I figured by this point, everyone would be sending uncompressed up to the cloud. With all this 5G and everything, no problem. But especially with sports, that's not the case. So we're having to deal with all these types of codecs and things like that. We're basically rebuilding Media Connect in order to get all of these Zixies and NDI, all that stuff going on. And then a fun thing for me, I really like this, the API-driven motion graphics stuff. It's the Singular Live. I don't know if anyone has ever dealt with these people. They're great. They are a really great organization. I love working with them. And they do cool stuff. And so, but what it means, though, is that you end up having to put what I would call an impure system in this case it's like Ceph, which is the Chromium runtime. Suddenly you have to incorporate into your system, and if you've seen what we already did, where everything was broken up into little pieces, suddenly we have this big monolith that's Chromium. So part of what we're having to do is teach our control plane about these things. But so, obviously you would use a red-blue type arrangement with things like this. But in any case, it's I think it's worth going through all this effort. Other things we're working on is timing compensation, getting everything, all the stuff aligned for especially things like motorsports. There's a huge amount of cameras all over the place, and they really can't sync their time codes up to each other. So you need other ways to do that, and we're working on that. We also have to get standards conversion in. We are not building that. We're going to license that. And other things we're working on is basically a simplified version of our switcher for what we call the single operator case for some of these really lower tier sports where it might be one person, where we're actually building the web-based console, and we still use the proxy switching concept, but we run the proxy switcher in the cloud. And for a lot of the reasons why it's for all that resilience stuff. And sort of a really interesting thing that we're doing is capitulation a little bit to NDI. And we basically decided NDI is good enough for proxy. So, we do proxy editing on the ground. And so in this case, we're building a gateway, which I call a gangway, but we write as gateway. And in that, what we're doing is basically creating an NDI source system on the ground. People can use their existing NDI infrastructure that they've already been trained on for things like that. And the idea, what it does require is that hopefully that you've factored your stuff so at least the GUI and backend are separate, so that we can just run basically a headless thing in the cloud and send commands up to it from the nice little GUI thing they've got running on the ground. But this, I think, is going to be very interesting and hopefully useful for this target group. And the absolute toughest thing that we can put in here is replay. And so we're spending a lot of time working on that. And so, there's some really good NDI replay stuff out there already, and we want it in our stuff. So we're working on that, but it impacts the way our proxies get timed, impacts backhaul, it impacts actually the replay itself has to be sending more proxy content to everybody else on the production. So there's a lot of things, and so this is one of our really tough problems that we're working on, but we think it will be interesting overall. And things like NDI switchers are way easier. Because we just have to monitor what they're doing, and we can even can like query them to see like how they're built, so we can build something in the cloud that maps to their architecture automatically. That is actually a lot easier. But replay is the toughest thing I've been able to find, and that's what we're working on. And I don't know, some people were nodding their heads like, oh yeah, that was trouble. And Jialu's turn.
Did that sound like a lot? So when we started the company, we had this brilliant idea that we're gonna find the pain points of this process, because live production in the cloud is a big market. And once we find the pain points, we're gonna focus on that, and that's how we get our little piece of that big market. But if you work with Mike, what you hear every day is like, how hard can that be? Or, that's cool, let's work on that. Or, that sucks, I bet we can do better than what they did. So before we knew it, we are building every single component of the whole service. I'm not complaining, it's just a little bit too much for a two-person company, I feel like. Okay. But speaking,
what's a pain point?
What's a pain point? Ops is a pain point. But speaking of pain points, I think a real pain point is like moving towards the distributed remote production. I don't know what he's doing. So it's like, this is like a control room where operators and directors used to have. They can see these like big monitor walls where they have like dedicated monitors for every single source or effects, multi-views. And now that they can work from home, which is nice, it's cost-effective, it's flexible. They can even sit in a cafe. But what they lose is the access to the big monitor wall. And all they have is this small laptop screen, and it's really hard to see the small windows of the sources. So we're thinking, how can we improve this? How can we provide like a working environment they are familiar with, where they can see the video sources easily? So we're like, Mike is gonna demo something we're working on.
And we have to switch our, hopefully this will work. Do you see it? Do you? All right, cool. So yeah, that's basically, the idea is Vision Pro is like maybe, it looks like an engineering prototype, but it kind of works, and it's good enough for us to get our software put together. Oh, don't move, all right. So we've learned that it's really easy for me to make people get sick if they watch this and I move too quickly. So I have to basically pretend I'm a cinematographer, like Roger Deakins or somebody like that. And so I'm gonna try to move slowly. So in this case, like, as you can see, there's pass-through video. I can see Jialu, I can see a control surface here, I can see my little giraffe and my laptop. And then, but what we finally did is like, so we add this thing. So there's our monitor wall, and it's like really big, and it's just showing up above your head. So, and this is just a really first generation thing. This is all mapped onto a plane. We will add real geometry to it. But there's a lot of really cool stuff you can do with this. And in addition to being able to recognize control surfaces, there's other things like spatial audio. So you can have your program audio appear to be coming from in front of you, and have your intercom, like the director can be behind you, and that kind of stuff. So there's just a lot of really, I think it improves the quality, the experience of when you're doing remote production. And so And to me, I mean, I'm an old guy, and I really don't like looking at the laptop screen when I want to see big monitors. and so I think this is cool. Like, you know, I could be doing my production right here above your heads, and you know. So I think we're finding a lot of reasons to want to support this. You know, in addition to the fact that we think there's going to be a lot more immersive sports content in live, and we better get used to it and probably support it more in our productions. So anyway, that's just an inkling, and you know, I don't know how much you know about Vision Pro, but you know, you can basically move things around, make people get really sick with the video quality. The pass-through quality is a little fuzzy, but it's good enough. I think you could actually do real work with it right now. I certainly can wear it for hours every day, and it's powerful enough that you can do stuff like send a whole bunch of video and compose them all together, and it's really no extra work for us to actually put like every one of those on its own little rectangle and angle them in and all that kind of stuff. I just didn't do it because we were too busy. But so in any case, I just thought this would be like a little preview, and I think that things like this are probably going to help with remote production more. I mean, I know I probably look like a dork right now wearing this thing. But once the dork factor goes away, I think you'll be seeing a lot more of this. And it definitely helps, in my opinion, it definitely helps when you're on a distributed production to things like this. And of course, you can imagine there's a lot more that we will be adding in the future. Okay, now we're going to switch back before you guys get sick. They're already sick, she says. Okay. Oh, and something else I maybe should point out is I was tethered to my laptop with this cable in order to get a high enough frame rate to show up on my laptop. Otherwise, it would look really choppy, almost like media live JPEG every 2 seconds. So anyway. And you know, I think that if you look at things like what Apple is doing in the live sports market, I mean, Apple is really, I mean, making a lot of moves in immersive, and I think that you will pretty soon you'll be seeing there will be like a real market for live immersive, and they you know, they actually Next VR was actually doing live, or not live, but they were doing VOD VR type sports for a really long time, using a couple like Red Pros with fisheye lenses and everything, and that's all part of Apple now. So anyway, we think that'll be interesting coming up. So that's just a little point. Anyhow, that's all we're going to talk about today. We talked about a little bit about our internals and asynchronous, all the crazy work we're up to at the moment, and then a little bit of a demo, and just a little. We are 2 engineers. Our company is almost finished with the engineering, and it's time to start becoming a real business. And so we're going to hire our bosses this year, probably. If you know anyone who's interested in working with us and taking a company, you know, into the big times, we would definitely like to hear about it, because we're not going to do it ourselves. That part is for sure. So, oops. And yeah, Jialu made a nice little chat GPT thing I want to make sure to show. And there's our new CEO. They have to be wearing one of these. I think we're ready for any questions if there's any time.
All right. To start, the setup with the Vision Pro was awesome. Great job. And I think that is a great use of it with the multi-viewer, and you can have like videos. The whole thing's awesome. But the question is, can you go back to the N+1 slide that shows the redundant recovery node? I think you guys called it.
Yeah.
The question ends up being more of a case of, is it like, how does the recovery node know that it needs to perform whatever function? Is there like a command and control server that's not?
Yeah, that's part of the discussion about the control plane, which we didn't get into this time. But it's the control plane, and everybody else finds out about it just like very shortly after it becomes unresponsive.
I mean, because you're talking like, I think the gap was at 20 frames or whatever,
Right.
which is a very, that's like millisecond time effectively.
Right, and we can do that because we always have repair nodes running, and all the routers have to do is start sending stuff to it, and the control plane has to say, do your thing. And it turns out that the thing is almost identical on every one of our instances. They're basically running ME units, and and because we're in the cloud, we can take advantage of just a huge amount of bandwidth that's available.
Is there, so are the signals already kind of getting pushed to the repair node before it's in use?
Nope. I'll have to show you. I guess maybe we can
Yeah,
talk to you. Maybe we can talk to you and show, because I do actually have some really cool graphs that show like how repair actually happens.
Yeah,
and you can see like the buffer occupancy
really
and all that.
Yeah.
But I didn't think that we'd have to go in. We'd be able to go into that kind of
I'm
detail.
glad that you spent the time on the Vision Pro.
But I'd be perfectly happy
pitch,
to at some other time or a different talk.
Cool. Thank you.
Thanks for the presentation. And Mike, I think you were saying that the inter-node communication here is uncompressed, correct?
Oops. Yes, that's correct.
And so I think you're using the 1 second delay or that time and timestamps to then these EC2 nodes don't require EFA. Is that correct?
They don't require what? Oh, EFA. No. Yeah, we use our own user space flowlets. On AWS, we use our own user space
on a
flowlets.
standard EC2 NIC that you
That's
get
right.
in anything.
And
okay.
so all it really is, so we actually use 8 megabits for our uncompressed. It's RGBA, and it's actually 16-bit components we're sending around, and if you figure that ends up being like about 8 megabits. But we distribute that across several UDP flows. And on AWS, we actually use a form of forward error correction, the sliding window one that has really low latency to correct for the problems. But our problems, like on AWS, what usually happens is there's hardly ever a random error. Those are really easy to recover. But what will happen often is, not often, maybe at least once a day, is a switch will break or something like that, and the control plane will basically stop that flow for over a second or so until it catches up. And as we mentioned in our SMPTE paper, when we send packets over these multiple flows, we actually randomize which flow every packet goes to, and that actually makes a burst error turn into a random error when we have to correct it.
Right.
And so that helps us a lot. But on some other clouds, we do have to use ARQ for this. But
I was going to ask if you So on AWS, you're not using ARQ. It's just a small FEC.
That's right. And Google.
Okay.
But on some clouds, they don't actually have this same type. I mean, I was surprised to learn this, and you could tell if you look at our blog where we talk about this, is that on some clouds, they don't use the same type of network topology that AWS uses in their data center. And so we were noticing that when we had a failure, it would apply to, it was basically synchronized across many flowlets, and that's when we decided, we didn't really have that many independent flows. But what really happens on those clouds is that, unlike AWS, which throttles every flow, they let you use the full bandwidth. So in that case, ARQ works really well. And especially the fact that the round trip time is really, really low in the cloud. So, ARQ is great for a really short round trip time.
So the fact that you're not using ARQ on AWS, is that part of why you say most suitable for within AZs? I mean, because if you're going to another region, it's longer.
Yeah, so we still, right, if you, and we can actually detect this. That was another thing we mentioned in our SMPTE paper. We have these ways of detecting when we're, like AWS, if you're going between data centers, you don't get all those flows. And so we do have ways that we compensate for that. And we can, and the control plane can actually recognize, we can tell the control plane about that. But on the other thing on AWS and others is where we do have to pay for data transfer costs, we will compress. And we use HTJ2K for that, so because we don't have to pay a license fee for that. We do have a JPEG XS license, but we use that only where we're talking to other customers who are using that. So we actually went ahead and implemented both of those, but yeah. So we will use compression where we have to pay by bit, but like within an AZ or something like that, this works very well for us. And actually, the AWS and Google networks have improved just radically during the 4 years that we've been doing our development, and so it's becoming easier and easier actually.
Yeah. So another question, if I may, like I think sometime in your talk you mentioned you're kind of recreating Media Connect. I guess my question would be, why not use Media Connect to get sources to AWS and then kind of carry it on from there? Are there things that Media Connect doesn't have that make you have to recreate Media Connect?
So like we're perfectly happy to take Media Connect streams and and take them in like over CDI or something like that. But we are building a multi-cloud service, so we don't want. So we basically have to make sure that we can ingress and egress all of those formats on every cloud. So we don't want to rely on Media Connect. Much as I love the product, I mean, we built it, but we really can't rely on it. But we definitely will interface to it. And actually, in most of our examples, we show us outputting to Media Connect. So that's, it's a great product. I love it.
Thank you.
Mm-hmm.
So Mike, what's your take on NDI? Right, you mentioned that in a couple of your slides, right? But we see a lot of usage of people using NDI in the cloud to build live production environments and so on, right? So like, what does NDI not do that we need to do?
Well, most of the NDI stuff is Windows, and that creates some issues just for, the licensing situation to just get stuff running in Windows stuff running in the cloud is I hate to deal with that kind of thing. But the other is, technically, we really want full bandwidth, or we want uncompressed. We want the highest quality possible. And NDI is getting there, but it's a little bit slow, but we've already built that, so it works well. We don't need that for that. So the places where NDI is useful for us is stuff like on the ground, where people already have an NDI studio and they don't want to retrain to use like our switcher and stuff like that. So we want to leverage that. So to me, it's great that people are using NDI on the ground. I think it belongs there. That's where your GUIs ought to be, as we've said in our talk. So that's the other thing that bothers me about NDI is most of those things end up needing like a remote desktop connection to control up in the cloud. And part of our talk was describing why we think that's really a kind of an anti-pattern.
Yeah, I totally agree with the remote desktop stuff, right? You want a native web app, clearly, right? But that's actually not really an NDI thing. That's a product thing, right?
Right.
It's
just, it's a lot of it was COVID, and everyone was being very, pragmatic and like, okay, we suddenly need to work remotely, and we have this NDI stuff, and gee, guess what? It actually does work in the cloud if we, look at it with nice. So to me, it feels like an interim solution, and if I was really, I could say like they're using that because they haven't tried to use our stuff yet, or something. That's what I would say.
I agree. The remote desktop thing was very pragmatic, right? But that's separate from all the data plane concepts you're talking about, to me, right?
Yeah. I know. I think that I don't want to badmouth NDI or anything. It's just that we didn't need it in our implementation. And we are building software as a service. So, and we will accept NDI, and we'll send it out. So we can receive and send NDI from our service. That's part of the thing we added to do the sports stuff. But internally, we don't need it at all. And I think that if somebody does have something they're using in the cloud that's NDI and it wants to talk to us, we know how to talk to it. So we can do that. So. I guess that's the point.
Anybody else? All Right, so when are you going to build the virtual control surface inside the Vision Pro?
You know, I actually thought that I wanted to do that, and I'm not really sure. See, part of the problem is I'm really biased into, I really love hardware control surfaces.
Yeah, that's what I was going to say.
I mean, I used to operate a Grass Valley 300 switcher, gigantic thing, and you know, your fingers just know exactly where to go. You don't even have to look. And so, you know, we do build software GUI for controlling our system, and it would be very easy to do it virtually, and we probably will. It's probably demos well. That would be first.
Yeah, so I think that into thinking, is there a certain brand of control surface? I'm a musician, so I know a lot about MIDI controls, and then applications that run it, and all the mappings that don't work or do work. Is that a whole issue?
Oh yeah, well, like MIDI is a good example. So we haven't shown you anything with audio yet, but we do use MIDI control surfaces, and it's really interesting trying to interact with some of them. I mean, the new SSL ones are like really great, but in my opinion, you have to like act like your Apple Logic or something like that in order to talk to them. And so it's kind of a reverse engineering process, but that's definitely in line with the type of stuff we do. I mean, we do have those surfaces, and I have Behringer and stuff, and you know, I'm a real audio guy, and Jialu is currently working on our audio subsystem, and so.
Yeah, so we want to see that, Mike. We want to see that next month.
I'm sorry, what?
We want to see that working next month.
Yeah, okay, well.
By popular request.
How about like a month
Actually,
after NAB?
My real question is there a collaboration opportunity tonight between your team and M2A for M2A VR control?
Yeah. Yeah. Well, yeah. I don't know. I think we consider the MTA people to be our friends, and so I would love to be working with them on anything.
I mean, do you predict a future where you use the Vision Pro, right? You have some visibility into a physical, you know, the augmented part, right?
Right.
And that's that using a physical thing, you touch it, you know, you just said, you know where the buttons are, you know how it feels. And then you're, you know, overlaid on top of that, you have the multi-viewer,
right?
Like everything else you need. So maybe is that the hybrid approach? Is
yeah, that's the one that we like. And the other thing, like Jialu is going to kill me for this because we haven't filed everything for it, but. You don't
have to. Yeah,
I know.
Have to, like, I mean, yeah,
you know, I'm like the guy who likes to tell everything.
This live stream on the internet, you know, so
okay, you can recognize a control surface and have gestures that will allow you to do things like change properties and stuff. That is way easier than any
like
other way that you can
as
do
you
it.
Run through
so you want to change your wipe pattern or something like that. So easy to do this way using gestures, and so of course.
Right, yeah, so maybe that's the future. You ship somebody a laptop, a control service, and then the Vision Pro, and they get the visuals on there, and then they get to run the the mixer or whatever they're doing. You know?
Yeah, so I think there's a really big opportunity there, which is sort of why we had our CEO wearing one of those things.
Honestly, like I really enjoyed the whole like John didn't even be like, I don't know what he's doing. Like that was so good. You guys should really keep that going.
So what about optimizing for like you were saying remote, remote that sort of having your battle station there, right? What about the infrastructure like up to that, right? Is that why you focus so much on optimizing? Because like it's just going to be slow because people have whatever internet they have available, or is that really not something that it sounds like to me that's what the value proposition is. Like it's going to be faster than whoever.
Yeah, I don't know. I like to think I live in the future and I know what's going to happen, but I'm sometimes really wrong about the time frame. Okay, and like I said, I thought everyone would be uncompressed by this point. Okay, so it's really hard for me to say. But of course, we would love for people to have more bandwidth. And of course, we're talking to all the companies that are like especially sports people are using to send their media around right now and wanting to interconnect with them. I think that there are a lot of ways, but I do think that it's going to be a slow process. And that's also one of the reasons why if we have to do timing correction, is because a lot of times they're taking different routes that are really slow, and so and I'd love to talk about that part too. That's a really cool thing.
I was a little bit surprised
yeah.
that, like, with the Vision Pro, for instance, you don't have this like AR representation of the key, like just keyboards. Where it's all the same stuff. Why can't I just type on it? Like you were saying, your physical services.
Yeah, and Apple does have that to some extent, but still, like, I can tell you that it's a lot easier using a hardware keyboard
absolutely.
with the Vision Pro. And so they're really pushing the edge of the technology, in terms of, like, it's still a fuzzy display. It's still very heavy. It's definitely a developer release. This is all to get developers excited to build stuff that eventually, when they get the hardware figured out, that everyone else can be using. So
cool.
But yeah, in the meantime, we have fun with it. So.
Thank you.
I think we've got one more question back here. Mike, I live in the future too. That's why I thought Samsung TVs in 2016 would be gone by now, but they're not.
Yeah. Okay.
Or any other technology from 2010 and on. It's awesome.
So I'm just curious. My wife works with FIA around racing, and I've had the privilege of visiting some of their control booths and some of the racetracks. Watching you on the Apple Pro, I see that as something in the future, but I'm curious. I know the organization would be concerned about security, so how does that play into hardware versus software?
That's an interesting one, and I'm not sure how getting the Vision Pro in there is. You're concerned about, like, rights management or something like that through there?
FIA F1 would be very concerned about somebody.
See, so far, like with all of our stuff, we just make sure that we run everything on encrypted tunnels, and that's kind of our easy solution. And we're also setting up a process where our staff cannot see the customer's video unless they give us permission. There's little things like that are going on. But other than that, I can't say that we've spent a whole lot of time. I mean, we used to work at AWS. When you build services at AWS, they put you through this incredible security screening process, and we know how to build stuff securely on AWS, the things to do there. And I guess at the moment, we're just hoping that transfers over to what we're working on now. But it's clear, like, when we become a bigger company, we obviously have to have people who are focusing on that. But yeah, it's a really good question and an important point. And I would love to get an introduction to the people.
She's a couple months.
Okay.
I'm a big F1 fan myself. So. All right, any other questions for Mike or Jialu? All right, thank you, Mike. Jialu, let's put our hands together. And that concludes tonight's talks. We are here till 9, so about 20 more minutes for beers and social time, and then I think we got to close it up. So thank you all for coming out again, and we'll see you next time. I did forget to say, I think May 9th is our next meetup, May 9th. Yeah, so May 9th is our next meetup. Get that on your calendars now, and we'll see you then.